quality tools case presentation. A simple methodology is explained to make you understand how the 7 basic quality tools can be used to solve a problem. We have taken a problem from an industry, society being impacted by the environment across the globe. That's why we have taken a problem of environment, how the environment is affected, and how we can save the environment and prevent the people from being affected by the degradation of environment. We will see the case. A team of process persons in a thermal power station listed about 50 problems in their workplace which need to be solved to improve the process. Problems included from process, environment, safety, interdepartment problems, and management related ones, of which they have taken the environment as the most critical one. And they listed out about 50 problems. I'm not going to explain what are the problems. There's no necessity to do this because we are going to address only one problem. They have taken about 50 problems. This is first 10, second 10, third 10, and fourth 10. Finally, the fifth 10 items, of which they made use of the first tool stratification methodology, that is stratification tool of the 7 quality tools, basic quality tools. And here they are classifying them. Classification of the problems in 3 categories they have done. That first one, category A, problems within the capacity of the team. The second one, problems which can be solved with the help of other sections, other department people they can engage, or other specialists, other experts can be engaged to solve the problems. Third one, the management related and other cases. So management related, they don't want, because the involved in the management and solving problem will take long time. That's why they did not include those things. Similarly, the second case also they have not done, because which is under their purview and easy for them to solve. In those cases they wanted to take, that's why they've taken the category A. Category A, they classified 35 items, and category B 10 items, and category C 5 items. Of the 35 items, process related items were 27, environment 7, and safety 1. So environment cases were chosen for further stratification. They again further classified them based on the propriety, priority, and preference, and which need to be given priority, which need to be given preference, and which need to be the proprietary can be included in that, and those things they have taken. The team were working on that. The problem selected was frequent failure of oxygen analyzer at air preheater inlet. Actually, here how the process is done is flue gas, which is generated in the boiler due to combustion of coal and air, passes through superheater tube path, then reheated tube path, and economizer tube path. So finally, with less amount of flue gas, that is coal and air, should come out. That is what, and heat also should be very less. Oxygen analyzer is situated between the air heater inlet. Measuring oxygen percentage is the prime factor they need to analyze there, then that should be controlled. Flue gas which is coming out of the chimney should be very, very less. That is what they want. And then the flue gas is less, means oxygen will be more. So the oxygen analyzer will be analyzing whether flue gas is more or oxygen is more. They will be analyzing, and after that, that will be dispensing of. In between, if it is flue gas is more, then the electrostatic precipitate which is available there, and that will be the flue gas, you need to come out, and that will be sent back to the ESP. Again, it is purified, then the final output will come out of the chimney. This is what the system is. So the process is explained here. The cooling tower is here, the generator is here, and turbine is here, condenser, boiler, and from the boiler only it is coming out. So here we have the oxygen analyzer. So how much it is there, the oxygen analyzes, it analyzes, and after that how much time it need to spend on the ESP, it is decided, based on the analyzer output, then ESP finally brings out only the unwanted items, that is with maximum oxygen content. With maximum oxygen content, it comes out. This is what the process is. So they have used stratification, and final only one problem was chosen, and now we move on to the failure check sheet. So they listed out a few causes for the failure, that in that environment related and air oxygen analyzer case, and what are the problems they have, and they have listed out here. First one, protective sleeve failure, that is this is daytime also they have taken, nighttime also they have taken, and totally how much it is, that the data they have collected. So protective sleeve they have taken. Here you can choose that marking items, that is the bar marking you can make, and you can add all those things. Finally you have this value. So protective sleeve, electronics breakdown, thermocouple failure, the oxygen zirconia cell failure, heater element failure, other mechanical parts damage. They have taken all these things. The total is this much. Now the third tool they are going to use is Pareto chart of failures. Pareto chart of failures they have taken. See here, this is arranged. The bar chart is made for these listed out items. They are arranged in the descending order. So count is 72, 22, 21, 14, 10, and 8, like this. So the values, the name of the failure is given here, and here the counts also it is given. And the left hand side you can see the number of counts, and the right hand side you can see the percentage of count. So the total count we have 100. Total count it is 100. It is given here. So the percentage they have taken for each and every item, and cumulative percentage also it is taken here, and finally you have 100 items. So the Pareto chart is made. Here you find that 80% value, 80% it covers protective sleeve failure, thermocouple failure, and heater element failure. So these three items may be covered in that, of which need to be addressed first, that they have chosen using Pareto chart. Pareto chart helps us to identify the major problem which is contributing to the overall failure of that. So now they have used the scatter diagram. They have used positive correlation is exhibited here, and this is the scatter diagram. So the relationship between two items they wanted to check. That is, one is protective sleeve failure and the plant downtime. These two things they wanted to compare. This is how much it is. So it is a positive correlation. So definitely, because of the plant protective sleeve failure, the plant downtime is on the higher side. So positively it is increasing. So protective sleeve failure it increases, then downtime also it increases. So this is the relationship they found out from this. So now we have the cause and effect diagram. Cause and effect diagram they made. So cause and effect, main, machine, material, methods, and environment. Environment or mother nature they have taken. So the many items are listed out. So under each category, so man also a few items are there, and machine also a few items are there, and material also we have. And so totally about 14 important items they have listed out, and they are the causes for the failure of the oxygen analyzer sleeve that they have listed out. So under each category they listed out, that is a cause and effect diagram review they made. So man, the items listed out in the previous slide, what we have seen, the cause and effect diagram, whether they are contributing to this. So man, no significant contribution by the causes. Maybe small items, small changes if they make in the man-related activities, tasks, or the responsibilities, and the problems can be solved. So machine-related 7 and 8 can be considered as significant, and similarly method also 10 and 11 are invalid. Later found 12 also invalid. So 10, 11, 12, 3 items are there, and they consider all are not valid. And material quality matters a lot. So two things are important, that is machine-related items and material-related. So which need to be addressed again now. They collected further data on this, that is dust load in the flue gas 900,000 milligrams per cubic meter, how much it is. Then flue gas temperature 330 degrees Celsius, flue gas flow 700 tons per hour, velocity flue gas 32 microns per second, velocity 32 miles per second, distance analyzer 1 meter. Sorry, that is 32 meters per second. 32 meters per second, and this is 1 meter distance. Okay. Now, the next item, this is the graphical representation. Multiple items are there. So, graphical representation, you can see that is using high carbon steel ASI 1085, C85, and this one compared to mild steel, stainless steel, SS304 and SS316. This is better option. So, this particular thing is better option. High corrosion and wear resistant properties made for the preference. So they have chosen that is ratings of corrosion and wear properties. Number 1 is there, then poor and fair. 2, fair for mild conditions, fair to good, good to excellent, and normally excellent. So these categories they have taken. They are comparing they compared the mild steel, stainless steel, and SS steel, then AAC, carbon steel. So that they have taken. So of all these things, that high carbon steel, it is having normally excellent category 6, and others are very less. So this bar graph gives us the idea that 6 is better, and we can use high carbon steel, then definitely corrosion and wear resistance can be achieved. So the result what they have done, 0 breakdown of protective steel was achieved during the root cause analysis and improvement. So that particular high carbon steel they have utilized, because of that the problem is solved. And they found that when they made the protective steel corrosion and the wear free, and so many other problems are also were solved. That is, other failures such as electronic breakdown, thermocouple failure, oxygen zirconia cell failure, heat element failure, and other mechanical parts damage were also considerably reduced because of this. Maybe the protective steel failure, which was contributing to the other problems also. So then other maintenance activities also they can involve in that. So that particular time spent on protective steel repair, they can use for other activities, and better process can be achieved. So the failure will be, time lost for the production will be very, very less, and protective sleeve also, it lasts long for a longer time. So now they have to sustain this result. Sustaining the result is achieved through histogram and control chart. Histogram and control chart they made, and this is the histogram, number of failures, how many failures which has happened in the subsequent period they have taken. A number of failures, it is only one, that is there, 1, 2, 3, 4. So 4 is very, very less. So the maximum number of failures it has come down, and similarly the 2 failures during a particular period is longer. And if they start working on this particular problem, so why this 2 are happening, then that can also be solved. And here you can see the upper control limit is 4.57 and lower control limit is minus 0.531. So it is below 0, but below 0 will not be there, only 0 can be achieved. See here, most of the values are below this 2, below the 2, below 2 and below that. So we have better process on it. So upper side, if you see, it is very limited items. 1, 2, 3 items alone are there on 4, and 3 few items are there. If you try to address these, if you consider these 3 points as special causes, and if you try to address those problems, definitely problems would be much better, and even the mean value 2 can be reduced to 1 or below that also. It can be possible. So this is how the problems are taken, and 7 QC tools are used to solve the problem. So you can also start practicing 7 QC tools, take up cases, and use